Okay, I think it's time for us to start today. Good day for everybody, and welcome, and thank you for joining us today for Tekla Wednesday webinar from Trimble. I'm your host, Toni Kamala, and it's my great pleasure to introduce our today's webinar speakers, Mr. Matthias Lange and Mr. Patrick Lenga from LAP Laser, and of course my Trimble colleague Sten Turak. In today's webinar, we will focus on integrated workflow between Tekla structures and LAP's industrial laser projection systems. And quick word regarding about the LAP. LAP is a manufacturer of high precision measuring systems for different industrial sectors. And Mr. Patrick Lenga will talk about this a little bit more in detail shortly. Overall today, Patrick and Matthias will talk about LAP's solution and for companies producing precast, and of course we will also talk a bit about Tekla structures, and then we'll show how fabrication data from Tekla model can be transferred to a LAP system. Before we continue, I urge you to close all other applications, then go to webinar and also view in full screen mode. And please note that questions and answers will follow the presentations. But questions can be submitted at any time, but we will address them at the close. As is usual, this webinar is being recorded, and our aim is to post the recording this Friday latest. And the recording will be available on our Wednesday webinar page at tekla.com. But now let's move forward to our topic today. In today's webinar, our aim is to present how model-based working with Tekla and linking model information to LAP's laser projection systems can help to prevent errors and streamline overall the precast production. On this slide, you can pretty much see the summary of the workflow we are talking about today. With Tekla structures, the detailed model of building is created, and from model we can generate drawings and other documents for the production and erection purposes. And for those who are new to Tekla structures, I'll come back to this part more in detail shortly. And from Tekla model to transfer fabrication data to LAP systems, we can use file format called Unitechnic. We will also go a little bit this part through today. And with LAP's solution, data exported from Tekla model can be taken in use at factory to benefit production of precast elements. If you take a short look at what is planned to be presented, we begin with the presentation by LAP. Patrick Lenga from LAP US will present LAP as a company and talk about their solution for the precast fabricators. And after this, we go through a bit about Tekla structures, what is modeling with Tekla, and we will talk about Tekla's compatibility with other industry software and how to transfer data from model to precast systems like LAP. We also go through a bit about what is Unitechnic file format and what is included in data file when it's created from model. And after the presentation, plan is that we will go, or we will have a demonstration of overall solution by Sten and Matthias. And of course, at the end of the webinar, there will be a questions and answers. But now, let's move to LAP's presentation. I'm happy to welcome Patrick Lenga from LAP US. So, Patrick, please.
Thank you, Tony, for the introduction and for the warm welcome. Dear seminar participant, my name is Patrick Lenga. I am based in the LAP office in Cincinnati, Ohio, USA, being responsible for sales of LAP industrial laser product in the Americas. Today, I will provide you a brief overview on LAP as a company. I will also introduce our Concrete Pro solution, our laser projection system for the production of concrete prefabs. In 1984, LAP, being pioneers in laser technology, started to develop point and line laser units for industrial measuring systems. Today, LAP Laser Applikationen is an ISO-certified company providing quality laser solution to the global markets. We are active in 3 business areas, offering industrial laser projection, laser measurement, and healthcare solutions. LAP headquarters is located near Hamburg in Germany, and the LAP staff takes care of the company's worldwide customers through subsidiaries in the USA, Singapore, and China, as well as a network of more than 70 distributors worldwide. The focus of our business is to improve process, performance, and to assure quality within manufacturing lines. LAP offers a complete range of laser projection products for industrial use. We can project everything from laser points to lines, crosses, fast-moving lines, up to free shape on most 3D surfaces. We offer line lasers in different power classes, with different optics and different laser colors. All product being well suited for the harsh environment of industrial use. We offer several different sizes of servo lasers with up to 2,600 millimeters or 8 feet moving range and moving speed of up to 1,000 millimeters per second or 3.2 feet per second. Customer can select flexible configuration with red, green, blue laser module, adjustable in power, and fully controlled by PLC via standardized Ethernet IP control. Furthermore, we offer laser projection system consisting of advanced laser projection, functional reflector target, and a user-friendly remote control, and the feature-rich ProSoft projection software. All of the products are built to secure long lifetime and reduce service requirement. LAP laser projection products are being used in various industries worldwide, from tire manufacturing to rubber stone to concrete, aviation, and automotive. In the following section, I will focus on LAP laser projection system. LAP laser projection system is called CAD Pro and consists of one or more CAD Pro laser projectors, laser targets, and the user-friendly ProSoft software, and one or more remote controls. The LAP laser projector displays precise outline, templates, patterns, or other shapes on almost all surfaces. The laser projection is thereby based on CAD data provided by the customer. Changes on the CAD data can easily be implemented. However, one has to mention that certain data preparation work always has to be performed for laser projection. The projection surface may be flat 2D or curved 3D. The LAP projection system secures a correct positioned laser image of the CAD model line on the surface. The laser image of the CAD Pro model can then be used by customer to join parts, place layers of material, align parts, display work steps, control completeness, or support any other work with the help of the visual laser lines. Thereby, laser projector reduce time to production, improve output capacity, and reduce reject, resulting in fast return on investment. LAP laser projection systems are deployed worldwide in many industries, in particular in composite manufacturing for aircraft and wind rotor blades. LAP has created a specific 3-in-1 package to address the need of the prefabricated concrete market. The Concrete Pro package includes everything needed to start the laser projection on static or circulating pallet and any object placed on those. The projected laser lines are based on your technical drawing in CAD or Unitech file format. The data can be exported straight from Tekla structure software and then be opened in the LAP laser projection software. With Concrete Pro, you can optimize the process sequence and your production quality. In the manufacture of practically all prefabricated concrete parts, you can work faster, more flexibly, and more precisely than with mechanical templates, color plotters, or other aids for measuring and positioning. Utilize projection at the speed of light instead of time-consuming alignment using straight edges angles, or stops. In contrast to plotters, with which you must mark all the operation on the palette at one time, you can call up on the process projection files on a step-by-step basis using a remote control unit. Thanks to LAP Multicolor, it is possible to project images in different colors for different or important steps in the process. Or you can project the outline of an object onto the palette in green, and for verification purposes, project the profile of the position element on its upper surface in red. After production of the concrete part, it is no longer necessary to clean the color marks off the palette, since the laser does not leave any traces behind. Customers report to us fast, simple, reliable, and cost-effective solution that helps them speed up production by up to 25%. The generic setup for Concrete Pro solution is straightforward. The lasers are mounted over the work area. They can be attached to ceilings or beam in a fixed position or to pivot arms or rails so that they can move. The standard industrial PC control one or more laser projectors. The projectors depict the outline individually or simultaneously depending on the customer's specific requirement. The projection displays the shape or major profile segment on a 1:1 scale in the desired work area. The next item to populate the palette can be positioned precisely within the projected outline. In addition to outlines, letters and numbers can be projected. It is also possible to use user-defined signs and symbols. On this slide, I want to show you a real working example of your laser projection system based on 3 pictures. Image 1 shows how a worker in the factory hall uses a laser line for the placement of a formwork module for an opening. Image 2 shows the formwork module, and the green laser line indicates the correct placement. Image 3 shows how the ProSoft UT software compensates for the different height of build in components. I have reached the end of my brief company and solution overview and would like to thank you for your attention. At the end of the webinar and following the demonstration, you will have a chance to address any question related to LAP solution. Thank you very much.
Thank you, Patrick, for presentation. I think that gave a good overview of LAP's offering. Before going to actual demonstrations, let's talk a bit about Tekla and data transfer from model to LAP software. In Patrick's presentation, it was briefly mentioned how production data can be input to a LAP system. We talk about that shortly, but still, no production data is useful if it's not correct, which brings us to this slide, where I briefly want to talk about what is modeling and data creation with Tekla structures, especially for those in today's audience who are new to modeling with Tekla. What comes to preventing detailing errors and creation of correct, precise fabrication information, what is needed, we see that this is one of the key benefits achieved with the model-based working with Tekla structures. It bases on accurate models with detailed reinforcements, connections, embeds, and other fabrication information, which can be included in Tekla models. If we talk with BIM terms, Tekla is able to produce models with so-called level of development as high as 400 and 500 out of the box. If you are not familiar with the term level of development, I would like to guide you to check our webinar from last December, where we talk about this more in detail. But regarding to preventing errors, another aspect of this with Tekla is the way how the modeling is done. Thanks to unique technology for managing model and related data, our users can work in whole model of building basically just interacting with the model objects, which all helps to ensure that everything fits together. And also the utilization of general collaboration formats like IFC enables to share reference information between different design parties like architects and MEP designers. And by combining models, it's easy to make necessary changes to structural model and make sure that there are no costly surprises later in the project. When talking about drawings, with Tekla, the model is basically the source for building information and all different drawings, different reports, and other documents needed in a process. Basically, you ensure that model is correct, and after that, all the information in different document is correct, and it is consistent in a different documents because the source for all data is the same. And if project changes, you make necessary corrections to the model, and then changes can be updated to all relevant documents. And of course, Tekla comes with the ready-made templates, but users can customize their own according what is needed. For example, creating rules for different drawing views and how drawings of different element types should look like. That all helps to standardize and streamline the drawing creation process. On this slide here, you can see one example of customized fabrication drawing, which can be created with Tekla. It can be said that traditionally it might be that cast unit drawings are created in a way that all information is put on same drawing, on same sheet of paper. But when we think from process or actual production process point of view, it might be beneficial that everybody in production chain do not necessarily need all of the information. One way to make drawings more clear to read is to separate drawing to certain working steps, and so only information which is relevant for person who is reading the drawing. For example, group responsible of reinforcements have drawing with only relevant information for them, and group who is building the shuttering, installing embeds, and other concrete inserts, like for instance in today's topic, group using LAP laser projection systems. This group will only have information relevant for them in drawings. Like this, the drawings will be more clear to read. And basically, customization like this can be done centrally in company by one person, and then just templates created can be shared to all detailing teams. And one way to share company-specific templates like this is Tekla Warehouse. Addition to just drawing information, it's possible to create separate models of individual cast units from model by using file formats like IFC. Model files can be utilized with Trimble's mobile tools like Tekla Field 3D, which is a mobile solution, easy to learn and does not need any special computer skills to use. So Tekla Field 3D is quite easy to take into use and can be used on devices like tablets and mobile phones. And especially with the complex elements, easy to read 3D information helps to understand how the elements should be built, which might be difficult just by using drawings. But of course, it's not only about the drawings and models. Concerning today's topic with LAP, fabrication information from Tekla can also be sent to different production systems in digital form. Talking about Tekla's open system approach, addition to exchanging data with different design software, building data can also be sent directly from model to different production management systems and ERP systems. Some of them can be seen on the slide here. But more importantly for today's topic, Tekla is compatible with all leading production systems, and data can be exported from model to production machinery simply by using different industry file formats. Some of those like Unitechnic and PVBS. This is a quite busy slide and I guess all the details can be a little bit hard to see. But just to give an example, BBBS is a general file format used to send data to rebar bending machines and different rebar production management software. And Unitechnic is a format used for example, by automated mesh welding machines and different master computers, which are used to control soldering robots, concrete distributors, and pallet circulation systems, and so on, in automated production plants. Generally, there are some other file formats also used by automated production systems, which Tekla is fully compatible with and capable of producing. But this will be a topic for another presentation. But coming back to a Unitechnic file format, like mentioned already earlier in Patrick's presentation, this is the file format which is used to transfer data from Tekla model to LAP's systems. So in detailed model, basically, we have all the data and information needed to produce the elements. And with model, it's easy to ensure that there are no clashes, everything fits together, and the data is correct. And from Tekla, we can create a Unitechnic file for individual elements and transfer those files directly to a LAP system. And Sten will soon show how this is done. But before going to this, I just want to say a couple of things regarding the Unitechnic. Let's start with the question, how it is possible in one and same concrete precasting plant that equipment from different manufacturers can be combined with another. And if we ask that why it is that a laser is able to really separate different parts and objects in precast panel from data file and show the outlines, recesses, and unbuilt components, for instance, with the different colors or different sequence. To be able to do this, there is a common language needed so that the plant and system components like detailing software, soldering robot, mesh welding machine, or in our case laser, all from different manufacturers can communicate together. And this language was designed by a company called Unitechnic around the end of 80s. So in addition to a name of file format, Unitechnic is also a name of company behind it. Here you can see a simple representation of data file and what it contains. So in Unitechnic file, information about elements outlines, recesses, and openings is included, and this information can be sent automatically to a laser projection system. And in addition, position for different embeds and reinforcement information can also be included to our data files. And here again, production file content visualized with Unitechnic Viewer, which can be used, for example, to check the file content. But okay, let's see a little bit more in detail how this workflow actually looks like. We'll start with the Sten demonstrating Tekla structures, how data is created, how to create Unitechnic file, and transfer data from Tekla to LAP. And then we move to a LAP's demonstration. Matthias will demonstrate how laser projection system can be controlled with the LAP software and shows a bit how the laser outlines looks like. But we start with Sten, so Sten, you can start your demonstration. We just change computers.
Thank you, Tony. So I will give you a small demo about how Tekla Structures works here and how do we get these Unitechnic files from the Tekla Structures model. So we have here 4 buildings where we will find one inner panel, that's the wall panel, that's a little bit easier to use for the demo. Here, for example, we can find one panel with this one opening. Let's start with, for for example, doing the horizontal wall connection, from the component catalog, we search for the component, select the component, load the settings, apply them, and now we just select the elements between these elements we want to have the connection, and also the location. From here to here we would like to place the, and now we have the horizontal connection quite nicely, this wall shoes and connection between the foundation. So let's take a closer look of this wall panel, create the 3D view. Here we have it. So we redraw and see that this element already has all the shape, all the openings, and the openings are filled with green styrofoam. This is for the fabrication purposes. Also we have here these horizontal connection elements, the wall shoes, and also for the vertical connection elements for connecting with other wall panels. And for the transporting or lifting, there is the lifting anchors. So let's add some reinforcement also. Let's start with edge and corner reinforcement. Select the component again, the settings, apply and OK, and then use them. So here we can see that the edge reinforcement is placed quite nicely, and let's add some mesh bars also. Select the mesh bars. Again, the settings, apply OK, and the element. Here we have the mesh bars. Really quick demo also about adding the embeds. Let's add a steel plate here. Here we can quite easily choose the location, rotate it, later on move it also, and here it is. And now also let's add to this a sub assembly to this cast unit. So one thing more before start exporting, we have to number the elements. Start numbering and number the elements. Now once we have finished the numbering, we can select the element and file, export this to Unitechnic file. So everything looks good. Just in case, let's load the settings, apply, create. Here we can see parts exported successfully. And now there is always, we send also the drawings. So let's select the element and create cast unit drawing. And now here it is. Let's open it. So here we have the drawing that we just created. Here's the formwork with all the measures. Here is the reinforcement with marks, bar bending schedule with all the rebars, material list of the quantities, 3D views. So let's make a quick drawing also. Print PDF looks okay. Print, close, and now let's see how it came. Plot files, the PDF is here, and now the Unitechnic file also. Yes, this is the one. And let's send it to the LAP laser software that will take care of this file. We'll use it from here on. So thank you.
Thank you, Sten. And how we change a little bit computers here. And next we move to a LAB's demonstration.
Thank you, Tony, for providing the data. Welcome to the presentation of LAP laser projection. I will show you now how you can handle the data with the projection software and what the laser outlines will look like. As we don't do the webinar in a real concrete casting facility, I will show the projection on the office wall. Like always, you start the software with a double click. Our software is called ProSoft UT, the projection software for Untitled files. It provides the data for the laser projector namens CAD-Pro for a CAD projector. Several projectors may be controlled by the software for covering large areas. The basic structure of the desktop is quite easy to understand. Top navigation and menus like you know from other Windows applications. In the center you find the display area. And on the bottom we have some control elements. I will now open the file that Tony sent to me. As you see in the display, the correct data has been selected. You know the shape from the presentation before. In real life, you would have calibrated the laser projection system first. That's where the 4 reference marks in the display come from. And the palette for the production of this element have been placed in the projection area. On the lower left side, you can see the file structure as a tree. If you place the mouse pointer over it, you get the information concerning single elements shown in a pop-up window. Right beside it, you can select which elements should be shown. As you see, contours and cutouts have been checked. This is what you see above. The laser projection would look like this. If you check further boxes, the related content will also be shown. But this gets too complicated for working. In reality, you will display what is needed for the next work step, like starting with the cutouts. Showing the reinforcements next by selecting rod stocks horizontal and rod stocks vertical. The laser will not show the complete steel mats as you have seen in the picture. Only the beginning and ends of the rebar. The length of the beginning and endings can be defined in the initial configuration menu. If you enter a different value here, the start and end of the rebar elements will be longer or shorter. Please keep in mind that too long elements will make the projectors flicker. If you have to place single elements, it may even make sense to project vertical and horizontal parts separately. For prefabricated mats, you just need short markers anyhow. Back to the work steps. At the end, you maybe want to outline the mounting parts. The order of the shown elements depends on the production process. It may be different from case to case. At the bottom right side of the user interface, you can see the object height. If you project on the empty palette, this should be the standard value for your factory setup, typically 0. The value may differ if you place something higher above the palette surface. Normally, this should be defined in the data file. But there may be situations when you want to display the data of a certain height. One example is placing braced girders from projection on top of the girders. Clicking on Change Object Height allows you to enter the height of the girders at the new set value. You may show the actual height by activating the Height A button in the top row. I zoom in the picture to see what will be projected. If the girder height is determined and needed regularly, you may define buttons for recurring heights in the settings menu. Open the settings, configuration, standard heights. Here's one button with 120 millimeters. Now we have a new button for calling 120 millimeter height directly. So the selectable height is shown on mouse over. Now the height is activated and the height display shows 120 millimeter. Last but not least, we have the possibility to change the Y offset. This comes in handy when you produce double walls. If you turn over the dry part of the wall, you need to be placed exactly over the wet part. Sometimes the tiling works not as precisely as required. With the Y offset, you may move the projection to guarantee that openings for windows on one wall exactly match the openings in the second part of the wall. Before I close my session, I would like to mention that the workers can interact with the laser projection system using the portable remote control. You don't need to enter each work step at the keyboard. Our time in this webinar is limited, so I can't show you all features that support your work. We would be happy if you come back to us for more information. For today, I say thank you for watching and back to Tim.
Okay, now I got my sound working. So thank you, Matthias. Unfortunately, we were not able to show actual demonstration of laser in use. It's a bit difficult to demonstrate and get it visual, get the laser visual in a webinar. But I hope you got a good understanding of how LAP's laser projection system works and how visualization can be controlled by user at the factory. And I hope that you got an idea how fabrication data from Tekla model can be transferred to a LAP system. Okay, that was the presentation part of the webinar today. Before going to questions, I would like to use this opportunity and mention that for those who are close to following two events, Betontage in Germany at the end of February and Precast Show in Nashville, US, beginning of March. Both of the companies, Trimble and LAP, will have a booth in these events. So please reserve a date and come and have a chat with us and see both solutions more in detail. And of course, you can ask more questions also face to face. But now the questions of today's webinar. We have got a couple of questions during the webinar, and I will share those to you shortly. If you still have questions on today's topics, please submit them by us by using questions dialog box, and you can also send questions later on by email at tekla.webinar@trimble.com. Please notice the new address. But to the first question, I think we have two a little bit similar. The first ones go to Sten. So there's one question relating to Unitechnic. Can I export all elements with one file, or do I have to do it one by one for each element? So I guess then this is for you.
Okay. First of all, Unitechnic file format itself can include information about only one cast unit. And that's why every cast unit has to have different file. But don't worry, with Tekla structures it's not a problem, because you can export entire model or only selected elements with one go, so you don't have to do it separately. And for selecting elements, you can choose or pick the elements manually from the model, or also you can use our really efficient tool organizer that helps select the needed organized elements quite quickly and efficiently, and then export them as separate files.
Okay, thank you. And next question is also regarding the Unitechnic file. So then, does all information from model go to Unitechnic file, or can we exclude, for example, some embeds or rebars? So
yes, we can exclude, for example, embeds or rebars or meshes, and there are quite many different options to choose what and how we want to export these Unitechnic files. Although there are many settings or options, we don't have to set them every time. We can just use the pre-saved settings.
okay, thank you, Sten. And the next two is for the Matthias regarding the LAP. Let's start with this one. So, what are the errors most commonly made when using laser together with CAD data? How to avoid those?
Each installation has an individual environment and individual processes. Still, we often encounter discrepancies in the measurement data of CAD data of the objects we project on. If the palette rim or surface or the calibration marks are not positioned where the CAD data says they should be, the whole projection can't be precise. So, accurate measurement and correct data are essential.
Okay, thank you. And fourth one also regarding LAP. I guess this is more for the when the actual thing happens. How can a projector failure be handled if that kind of thing happens? So, Matthias.
Laser projectors can't be repaired on location. If you have a spare projector on site, you just change it. Switch off, disconnect cable, open bracket, change projector, aim system at workplace, close bracket, connect cable, switch on, recalibrate, and work on. Done nearly as fast, I'm telling it. Then you chip the defect projector to LAP and receive it back as soon as possible. If you have no spare projector, you contact LAP and ask for a temporary replacement. We will send it out as soon as possible. After contacting LAP, you can dismount the defect projector and send it to LAP.
Okay, that was quite straightforward. I do believe that we have time for one question more, but before going there, I would like to remind you again that you can also send questions to us by email. Address is tekla.webinar@trimble.com. And I know we haven't answered all your questions during the webinar. We will get back to you right after the webinar via email. Also to mention, at the end of the webinar, there will be a short feedback poll, 3 short questions. We would be glad if you would take a few seconds to respond to these. But before final question, next webinar preview. In the first week of March, we have a series of webinars coming up. Actually, it's again time for sneak previews for new version of Tekla Structures. So starting on Tuesday, 1st of March, we have a set of 4 different webinars introducing latest developments done for Tekla Structures or Tekla software. Great new things will be introduced with the new version, so please go and check out our website. More information about the content is already available at webinars page at tekla.com. But the last question, I think this will go to Sten again, and it's regarding drawings, which we saw on the presentation. Drawing example which you showed with 4 different drawings create for same element. will this type of drawing create 4 different drawing files of same drawing?
No, it will create only one file where we can have all drawings on different pages. And all drawings have the same drawing number, but each page has its own page number, so we can make the difference of the pages, and also you know which sub-drawing belongs together when you print the drawings out.
Okay, thank you, Sten. I think that was the last question what we can take today. And I think it's time to end our webinar. For all our listeners, thank you for being with us. Thank you, Matthias. Thank you, Patrick. Thank you, Sten. And for goodbye till next time.